welcome back. We're working with this scatter plot. So far, we have seen that we can control the shape and appearance of the markers. Something else we should consider is a sort of story that we're trying to tell and how we can emphasize that story. Now, we're saying that the S&P 500 and the Dow Jones are correlated. And this begs a question. What do we mean by correlated, and how correlated are they? One thing that we could do in this particular case is essentially create a situation where the axes run over the exact same set of values, and then the plot is square. And this allows us to directly control or compare how these two things fare. So now we're talking about controlling the aspect ratio and controlling the span of the axes. So let's go ahead and change the aspect ratio first. That's part of how the overall look is, and so that's going to be a function of layout. And in particular, we have access to parameters of width, where we're going to supply this in terms of pixels. I tend to think of typically having something at about 300 dots per inch in terms of resolution, and maybe putting this in a paper. So maybe I'd want that to be like 3 inches across. And so that gives me about 900 pixels to try. And then height, let's also have that be 900. See what it looks like. It's not too bad. The reason you sort of care about this is, let's say I went with 300 and 300. We haven't changed the font yet, and we're going to learn in the next video how to do so. But the fonts end up being sort of large enough that the axes fonts overlap, and it gives you this kind of like tilted angle, and I'd have to adjust all the like sizes of these individual points and things like that. And so another reason to make sure that we pick good widths and heights is that we'll have reasonable looking text values here. This is a little big, you can actually see, and so maybe for the sake of this particular video, we'll cut it roughly in half and have it be 500 and 500. Still looks okay. Now we've made something where the figure itself, okay, is 500 by 500. It's square, the actual canvas, but the axes may not be. And the reason is that there's sort of margins on all the sides of this plot. And if the margins are slightly different sizes, then we're gonna have the plot area not be square. So we also need to think about the fact that there's a margin. And that's gonna be a dictionary, and we're gonna just specify the left side margin. Let's say 50 pixels, right? It's 50, and then top is also, we probably don't need 50 here, but let's go ahead and make the top and the bottom also equal to 50. So just margin. All right, now we have something where this plot area is probably pretty darn square. Looking at this, you might think we can just compare on this line, but actually I can look on the x-axis and I can see the values run from 0 to just over 300. And then I have the same on the y, 0 to not quite 300. So in order to also make sure that these are square in terms of their values, we need to adjust the range of values that we have. And so in our axes, we can specify the range. This is going to be a list where we list the starting and stopping values. So how about 325,000? And we want this in both places. And so one way to do this is to just copy and paste this up here. You could also make a variable that holds this list and then assign that variable to both of these places. But now we have the range set so that it covers everything. And so this really is a pretty nice square plot where we're seeing all the values and we can see like how they deviate one from another. Now, we could try to improve this plot if we wanted, and this is a little outside of the scope of this talk, but I think it's worth just mentioning that we could add another scatter if we wanted that's just a line at 45 degrees. So we could say fig.add scatter, I could say x. What I need are 2 points that run the full range of the x values, so 0 to 350,000. And then we need y values that are the same. So let's just copy and paste this and retitle that as a Y. We'd like this to be a line, and so we'll say mode equals lines, and then we would like the line to be black, so line dictionary color equals black. And then when I run this, what I will end up with is this line here that's running at 45 degrees. I obviously did not type in 350,000, so we need some extra zeros. Now I have that line. The line, I kind of actually want it to look like the axes, so let's also go up and say that I would like the width to be 1, and then that'll look similar to the axes that we already have. We don't need to show the legend in this particular case. That's under layout, so we'll say show legend equals false. All right, so there we have it. Now I have a square plot where I have a line at 45 degrees, and I can immediately see that basically the Dow Jones price is almost always higher than the S&P 500 price, even though they are strongly correlated. And so we could change the title if we want. You can also see that the title here was broken because we made the plot too small, and so it runs off the edge. When we talk about how to handle font in the next video, we'll fix that there. Okay, and so other things that I want to talk about is that there's aspect ratios other than square that we could use. In fact, I think for the most part, square is the wrong choice, okay? Most people don't like looking at squares. If you think about like computer screens and TV screens and phones and paintings and windows, like none of these things are square. All the things that we spend a lot of time looking at in our life are not square. So unless you have a very good reason to make a square plot, like what we have here, you probably want to use an aspect ratio that is different from that. And so what aspect ratios might we use? Well, you could use aspect ratios like the golden ratio. So let's imagine that we didn't want this to be a square plot. The golden ratio is roughly like 1.6 to 1. So I can actually just exploit the fact that Python does math and say I want the width to be 1.6 times 500, so 1.6 times wider than it is tall, and I'll get a plot out that's the golden ratio. This is actually pretty close to what Plotly makes sort of as its most basic choice. Other things that we like looking at might be 8.5 by 11 paper, right? So what if this was 11 divided by 8.5 times 500? This will be the aspect ratio for a piece of US letter paper, which we're also used to looking at. And so you can explore other aspect ratios and justify why you might want to use one versus another. For instance, let's go back to this idea of trying to have this be a square plot. And the reason we wanted a square plot was because it was easy to compare these values. But something else that we could think about is that people see differences in trends best when the data that we're looking at runs at 45 degrees. And this line here is at 45 degrees. Our data's not quite on it, actually. And so if we wanted the data to run at 45 degrees, we would need the height to be ever so slightly taller. And so you could take something on the screen that you know is at 45 degrees and change the aspect ratio until you get the data to run at 45 degrees. And that's another way to choose aspect ratios. This is all discussed in the reading for the course. And yeah, so you can make choices however you want. In general, again, I would say make things that are not square unless you have a very good reason to make them square. Just be able to justify the choices that you're making. Now, this is really all we want to say about this video and controlling aspect ratio. I do want to take one moment to just point out a few things I would change if I was continuing to work on this to make it look good. We're not worried about making things look amazing right now. We're just trying to learn how to control different aspects of the plot. But I see different numbers of tick marks here and on the X and the Y, so I would probably change the Y axis to get rid of those tick marks. I would align the title, I would break the title, and I might play around a little bit more with the markers here if I could. Otherwise, I think we're off to a pretty good start, and that's all I have to say in this video.